back, since we have defined the customer item metric before, so you know the customer item metric. What is this data frame means? So it calculates the quantity which product they buy for this metric. But for this one, customer item metric 01, this metric identify each customer buy which product. So if this customer didn't buy this product, it indicate 0. If it buy the product, it will identify with 1, like this one. Okay, so for this customer, he buy these 2 products, like this one. This customer buy these 2 also, and for this customer buy these 3 products also. Okay, so next we are going to talk about correlative filtering. In Chinese, we call 协同过滤法. So what does this filtering means? Is we have to correlative filtering is a method to making automatic prediction filtering. So we have to make a prediction about what is the interest of a user will be bought, and it will to reference the information from many users. So we call correlative. So 协同. So you can find what kind of correlative filtering, so you know the behavior for most of the users. If they have the same behavior, so you can make a prediction what kind of food, what kind of product the user can buy. So we can make a prediction, and we can do the recommendation for these users. Okay, so there are 2 types of correlative filtering. So the first one we call user 使用者对使用者之间的similarities. So we call user correlative filtering. So we convert the most similar customer group user similarity metric. So later we'll create a user similarity metric, and to check the product they are frequently bought, and then we can do the recommendation for the lock customers. So first we have to create this one. Okay, a user correlative filtering. The second method we call item correlative filtering. So it related to the product. So we have to find out the product group. So what kind of group the item they will buy together. So we have to create a item similarity metric that is most familiar to the current view product, and recommend it to our customers. Okay, and also we'll find out which product are often bought together. Okay, so we have to import cosine similarity function, this method in the first. So we have to import this scikit-learn, this one. Okay, so we use this cosine similarity. ，OK， 为余弦 ，OK， 余弦相似度 similarity. So you will find out the users to users cosine similarity metric, okay, in this part. I think it's very easy for us to do this cosine similarity metric by using cosine similarity function. So we don't have to do a lot of computations. We only need to call the functions, and we have the customer item metric 01 before. So you just have to prepare this customer's item metric in the beginning, and then you can call the cosine similarity function to do the user to user cosine similarity metric. It will automatically create a user to user cosine similarity metric for us. And then we transfer the result as a data frame. So we first to use cosine similarity with the customer item metric, and then transfer the result to data frame. And we keep the result as user sim metric, similarity metric. Okay, so let us to run these instructions. It doesn't take too much a long time to create this metric. Okay, so let us to take a look at the user similarity metric. What does this content? Okay, in this metric you will find out. So there are let me see how many. What is the dimension? 4,339 by 4,339. So in the previous section, we know the customers, how many customers for this transaction? So there are 4,339 customers. 有4000多个客户。So we do to create the user similarity metric. For the customer 0 and 0, the similarity is 1. It's the same. Okay? So here you will find the similarity with each one. It's so easy for us to use cosine similarity to calculate the user similarity metric. Okay, so let us find out the first row for the matrix. So here you will find 0, 0, the similarity is 1. 1 and compared to itself is 1. 自己对自己就是1. The similarity is 1. Okay? For the tail, last 5 row for this matrix. Okay, so you can see the dimension for this matrix. Okay, 4,339 rows and columns. Okay, so in the index and for the columns name, they only to keep the numbers. So later we have to change with the column ID in user similarity metric. So we have changed the customer ID with the 1, 2, 3, 5. Okay. So okay, so let us to run this source codes. Okay, with this one you may find, so we get each customer ID instead the numbers. So we find the customer ID 1, 2, 3, 4, 6. You will find this one with rest of the customers. In this data frame, you can click the column name to do the sorting. So you will find the first one, the first related customers with 1, 2, 3, 4, 6. The most relative is this customer, 1, 5, 5, 2, 6. This customer has the most similarity with 1, 2, 3, 4, 6. So you may find the top 10 of the customers related to these customers. Okay, it's so easy for you guys to do this sorting. The tail, the last 5 codes. Okay, so next since we have created the user similarity matrix, so you find the similarity with each others. So we have to make recommendations for product. Okay, so we take this customer ID as an example. 1, 2, 3, 50. These customers as an example to find and show customer ID with most similarities. So we will find the top 10 similarity with these customers. Okay, so here we can filter with this customer's ID. Okay, so here you may find the color with this one. Okay, and then we have to sort from big to small. Ascend as false. We use this function sort value. Okay, with this function you may see here, so you find itself. So you may find 1, 7, 9, 35, 1, 70, 1, 79, 35. These customers with the most similarity with the target one. Okay, so here we can find the top 10. We just to keep the header to top 10. Okay, here is the top 10 similarities with these customers. Okay, so with this function we can omit the the cell, the content with 0. Okay, so here we can find to escape the numbers with 0. We only retrieve non-zero data. Okay, so here we define item bought by A, which is by 1, 2, 3, 50, this customer ID. And also we set customer ID metric, so we retrieve this customer's ID, and with this one to numpy non-zero with index. So with this function, you may find what kind of product this customer buy. So he buy this kind of product. So we skip the product with 0. So here is only 1. So he buy this kind of product. Also, we have to check with the most similarity with this one, which is 17935, this customer ID. So we defined the item bought by B. Okay, so here we have to filter the product bought by A and the product bought by B. And then we have to subtract with A and B, so you may find its item to recommendation to B. So you may find the product. Okay, so this is the product list. The product recommendation list for B, which is A buy and B didn't buy. So we recommend this product list for B. Okay. Okay, so we have to retrieve the product name for the recommendation. So we recommend this product for customer B. Okay, so for our next section, we are going to introduce the item-based cooperative filter. So in the previous section, we talking about the users cooperative filters, 客户跟客户之间的 similarity filter. But later, I would like to introduce the item cooperative filter. So what is the relationship between items 货物之间的? So the item-based cooperative filtering, we use the same function, cosine similarity function, and we use the same metric as we did before, customer item metric. So you may see here the custom metric, this one. Here is the customer's ID, and this one is product ID, right? For the column name. The index is for the customer ID. For this one is column. The column name is for the item product code. But we have to do the transformation to change the index to column and the column name to index. So you may see here, we stop T to do the transformation. So here you can see we exchange the index as code, start code, and we change the column name with the column, customer ID. Can you tell the difference? So this one is our previous customer item metric, but with stop T, this one is item customer metric. So with this one, the index is customer ID for the index. For the column name is start code. But we do the transformation. It will change the position with index and column name. So here, index is start code, 产品的编号. And for the column name, we use the customer ID instead. Okay, so with this function, we can calculate item similarity metric. Because the index, we use the item stock code instead the customer ID. Okay, so we get the item similarity metric. So you may find the item similarity metric. So you can see with the items similarity matrix. But then we do the same process to change the stock code with each customers, with each stock code. 我要改变产品的编号。Okay, so we check the item similarity metric again. Okay, so here you may find we have the stock code for each one. Like our user similarity metric is the same. So this metric is for item only. And the previous metric is for users. Okay, so we can do the same thing to check to make a recommendation list. We slice with this one. Top 10 similar list. Okay. So we find out the top 10 similarity item. So it's as a group, similar items. And we also to name the items descriptions for our use. Okay, so we create the top 10 similarity items for our recommendations. So with this one, 2, 3, 1, 66. So with this one, so the rest of the stock code is the higher similarities. So you may, if someone buy this product, and you can recommend the rest of the recommendation list, item list for the customers, because this is a group for the customers they frequently buy it. Okay, that's all for this chapters. So this chapter we are talking about the product recommendation systems. So you have to find the data from our online retail, and you can do the product recommendations to your customers. Also, you can have the recommendation list for your product. Okay, so I hope you guys can understand all the content for this chapter, but it's some kind of complicated, but you have to exercise all the source code which I have provided you this week. Okay, see you guys next week.